Right, so we've got a differentiation question that's slightly different. So they give us a curve, y equals 5 minus a half x squared, and we see that's an inverted parabola. The point P is on that curve, so that means that P satisfies this equation. So if P satisfies that equation, it means that P is x, and the y coordinate must be equal to 5 minus a half x squared. Okay, now the question A, it says, show that OP squared is equal to that equation. Well, if we imagine that that's our OP, okay, well, let's think about this like Pythagoras, okay? So we've got our distance, basically our x distance, which is x for P, take away 0 for O. And we're going to square that. And then we're going to do the same thing for Y. So we're going to get 5 minus a half x squared minus 0 for the origin. And I'm going to square that. Okay, so now I'm going to square these. So x minus 0 all squared. Well, that's just x squared. If I square this, well, I can forget the 0 because that's not doing anything. So when I do this, I get 25 minus 5x squared plus 1/4 x to the power of 4. Okay, and then when I collect these terms together, because I've got my extra x squared, I've got 1/4 x to the power of 4 minus 4x squared plus 25, and that is OP squared, my line squared. So that is my A taken care of. Now it says find the values of x for which f of x, our derivative, is equal to 0. Okay, so we know how to do that. I'm going to work out my derivative. So my gradient function, or my derivative of f of x, is going to be 4 times 1/4, so that's 1x to the power of 3, minus 2 times 4x, which is going to give me 8x. And then basically remember that the 25, when we differentiate a constant, that's just 0. So my derivative is that. Right, so now I want that to be 0. So x cubed minus 8x equals 0. Well, let's factorise it. I've got a common factor of x. So that's x squared minus 8 is 0. So now I know one of my solutions is x equals 0. And the solution to the bracket means that x squared is equal to 8. So x is equal to the square root of 8. But remember, plus or minus. So now I've got 3 solutions to my cubic: 0, and plus and minus the square root of 8. Okay, so that's that. So that's B taken care of. Now I want C. It says hence or otherwise find the minimum distance from O to the curve. Well, we've already worked out what OP is. Okay, so we know OP. What we need to do is we need to minimize OP. Well, how do we do that? Well, we'll take the second derivative of our function, which is going to be 3x squared minus 8. Okay, we need that to be a minimum. So let's put our solutions in. So the second derivative of 0 is just minus 8. That's less than 0, so that is the maximum. If I take my second derivative and I put in the square root of 8, I get 3 times the square root of 8 squared, which is 8, minus 8, which is 16. So that is greater than 0, so that is the minimum. Okay, so now I know, and again, if I put in minus the square root of 8, I'll get the same answer, I'll get 16. So now I know that that's my minimum, but I've got to find the distance. So that means I need to work out what OP is. So if I want to work out what OP is, I need to sub this into my original. I need to do f of the square root of 8. And that is going to be, this is basically, so OP was this, so then I'm going to put this into this, and I've got, what am I doing? Right, so I'm going to put this into OP. OP is a quarter times the square root of 8 to the power of 4, minus 4 times the square root of 8 squared, plus 25. Okay, well, the square root of 8 raised to the power of 4 is actually a quarter of 8 squared, minus 4 times the square root of 8 squared, which is 8 plus 25. So that means that this is OP squared, remember that's the function we just substituted into, is equal to 9, and therefore OP is equal to 3. We can ignore the negative because it's a distance, so we can't be -3, so it's plus 3. And that's it solved.